Hey guys, so today you and I are going to talk about good enough. So let's get into it. So the question in question was, hi Frederick, how do you convince your team of developers and designers that, as you said, are expert in their craft, that they want to produce the best quality possible to do good enough code design without feeling shitty about it? Especially in software houses targeting startups, most of the time I spend overlooking quality and people. No, most of the time I is spent overlooking quality and people get frustrated about it more and more. It is only explaining the business standpoint. Is it only explaining the business standpoint and the bigger picture where we are in product life, or do you have the thought of, or do you have any thoughts on how to change people's mind on the work that they do? So this was posted on a video I made, which is called "Why Do IT Companies Prioritize Speed Over Quality?" And the basic argument that I make is that, well, that's only true to a point, and the main reason why there's usually a discrepancy between, if you ask, say, the software developers and the designers, like, do you have a good system versus the people who are actually selling the system and so forth. It is a matter of opinion. Like, quality is subjective. So for a software developer, for example, they will look at quality with the eyes of an expert, which usually means that they will have a fairly high definition of what quality is, like basically peak levels, whereas the person who's selling the system or buying the system and so forth might have a very different opinion because their understanding of these things is at a lower rate. And that goes for anything really. If you're an expert in something, your standards might be higher than anybody else. And so if you want to change your software developers mindset here, you need to teach them something, I argue, that a lot of software developers don't fully understand. I would say that when you understand this is when you've gotten to become a true, as I like to call it, a master, like a master craftsman. And it's not necessarily, this I argue is not restricted in any way to, say, software or anything like that. You can see the same thing in art or any crafts whatsoever, where you as a master have grown to a point where you can do everything, basically, where you can take something that is super 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 complicated and break it down and make it super nice or super intricate. Like, let's say you're making music or art or something like that, you can take like a piece of paper or something like that and draw a highly detailed image that looks like a masterpiece. But you can also sit down and in just 2-3 minutes make something that is a lot less complex but still looks nice. Or if you're a carpenter or something like that, you can create these like really advanced buildings or constructs that you might be building, right? Or you can make a really nice and simple pocket knife. And that's the thing that we software developers usually, I argue, or rather the ones that aren't really at the master level yet, have a bit of a hard time with. So what I usually see is that the software developers, they associate complex code and really fancy tools or things like that, and scalability, future proofing, all of these sorts of things, right? These more large scale concepts with good system. And that, I argue, is wrong. That perception is wrong. It is the equivalent of saying that anything that is not, if we take, say, construction work again, if you're building any building except for a modern day skyscraper, then it's bad. And I argue that is a very weird way of thinking, because surely anybody who looks at things in that perspective would understand that, well, not every single contract, like every building we're building, needs to be a skyscraper. It does, or a medical facility or a nuclear power plant. Like, there are many types of buildings you might want to construct. And even though you may not be building a super, super advanced thing, it's still pretty important that you make sure that the building that you are building, even if it's, I like to make the analogy to a shed. If you're going to build a shed, well, at the very least, the customer should, you should be nice enough to the customer to make sure that that thing holds up if there's a bit of wind going on or something like that. And that's the thing that is difficult with some software developers, because you're asking them to build something that cannot be a super advanced super system with like microservices and Kubernetes, or it doesn't matter what it is, right? They immediately associate that with bad code, like we're going to build bad code. Or if you have a sharp deadline and you can't run every single test or like more advanced features or things like that, even for the smaller system in the startup world, for example, they associate immediately, oh yeah, we're going to build a shitty system. And because they feel that means that they feel unmotivated to do a good job. And that is the thing you have to help them understand, that if I ask you to, in a very short amount of time, just as with my little drawing example here, I'm not asking you to just like doodle all over the whole fucking paper. It should still look well. It's just that you cannot take 3 weeks to do that thing to make it as perfect as you want. You have to restrain yourself a little bit and make the best with what you have. And that is something that it took a while for me to learn how to do that, but I like to call it, you need to be able to write shitty code really well. And I don't even like to call it shitty code, because I just call it simple code. And so what I do in order to help my software developers understand that is that whenever we design a feature, when I sit down with them, or assuming now that I'm a tech lead, well, I even do this when I'm just a senior, honestly, I just ask, okay, so how do we solve the problem that we have been presented with in the simplest way possible? And that's the key thing. Not bad, simple. And in some cases, just the other day, I had a guy who I had created a little client that connects to the Azure DevOps API in order to fetch some metrics and stuff like that. And so he pings me and he says that, oh, Frederick, like your client here, it takes a personal access token that you can create yourself, basically. That's pretty bad. We should use the service principal, or like we should configure a more elaborate solution. And I asked, why? And he said, well, because it, like in this case, he hadn't configured it correctly. He said, yeah, because it expired, like the path expired and stuff like that, and we have to change it. And I go, well, yeah, you can probably fix that with a service principal, but you could also just extend the lifetime of your personal access token. And then he immediately goes, well, yeah, but what if somebody quits? Like if I quit the company, then what will we do? And my first thought is, well, then anybody else who works in your team would need 2 seconds to just replace that thing, and then we continue. Or are you saying that we should create this more elaborate solution, or like this more advanced thing, right? And basically redo a bit of this work just in case of somebody quitting. Like, are you going to have people quitting every 5 minutes or something like that? It's probably like not that much of a common event, right? And he wasn't really happy with that, because in his mind there was a better way of doing it, and he might have been correct in the situation. My argument to him was basically, this is a very simple solution. For most of our juniors especially, it's going to be a lot easier for them to just create a personal access token. Like, that's going to be a lot faster than configuring like the service principals and stuff like that. There are way offs here, right? And the same thing goes for your startups and for you everything else. Like, I always ask them, like a classic one is like the people who want to automate all the things, and I say, all right, so how long is it going to take us to automate A, B, and C? And they say, oh yeah, I'm not sure, we're gonna have to do some investigations and stuff like that. And most of the time it's something trivial, like getting like a ping in the channel to make sure that you remind to update, or like that you get an alert or something like that. And I go, okay, how much time does it take you to do this right now? And usually they go, well, it just takes a few seconds. Okay, so if you think about it just practically, so it's going to take us days and weeks to implement an quote completely automatic solution to a problem. But if we do this, you make this shell script, or if we just create a reminder to do this or something like that, it takes 5 seconds, and it's something we barely ever do. And so I force the developers to think in those terms. I'm trying to push them as far back as possible in terms of how complex their solution can be. And then when I still tell them, great, now we agree on that there's a really simple solution. Now make sure that that solution is really, really well working. Because even if you create a shell script, or like, I don't care how you solve it, I still expect you to ship something that will be like tested and future proof, or like so forth and so on. It should still be a nice solution. As with my shed example, just because I ask a builder to not build a skyscraper, it doesn't mean that he's allowed to just like put up like 2-3 planks and then call that a shed. He still needs to produce a really nice shed. It's just not as big of a solution as a skyscraper. So what I want you to take away from this is that if you want to learn I argue that if you want to have software developers do a good job under all circumstances, you have to teach them the difference between shitty code and simple code. Because whenever somebody hears MVP or easy or small scope, like for most 99% of the developers out there think, oh, hacky, bad solution. And I teach them, no, not hacky solution, small solution. Simple solution. It can be a shell script, it can be a reminder in your calendar, I don't care what it is, but you should still make that small thing work really, really well. Just as with my analogy with the building. There are different buildings, different customers want different solutions to different problems, and just because your customer doesn't want like a gigantic skyscraper doesn't mean that you have the go ahead now to just create something that never works. You should still treat that with the same respect and make sure that you understand different testing strategies and quality patterns and stuff like that, because even when you're building a really small system, there are grades of how good that can work. You can make it super well, or you can make it super shitty. And most developers, for whatever reason, as soon as the system isn't built with basically Google standards, or like where they don't feel like they can fully leverage the massive might of all the various technologies we have at our disposal these days, then it's a shitty system, or it's not going to be a good system, or so forth. And I try to teach them that's your ignorance. That's when you're in the philosopher stage. A true master craftsman in any craft knows all the techniques. They know when to do something super advanced because the situation requires a super advanced solution, but they don't add complexity just because. They try to make sure that they dial it in a little bit, like how much effort do I have to put in order to meet the expectations for whoever I'm building this thing for. Have a great day.